This video is about geometry and it continues on with the calculating angles section of chapter 10. So in the last video we spoke about supplementary angles, complementary angles, and angles in a full rotation. Take a moment to think about these three rules and see if you can remember what they actually relate to. If you're a bit hazy on them, go back and re-watch that section in the previous video. In today's video, we're going to look at another rule, which is called vertically opposite angles. This is a very straightforward rule. If I have two straight lines, like I do in this diagram, that meet at a point, then the angles that are across from each other are equal in size. So my yellow angles are equal in size, and my blue angles are also equal in size. This rule can speed up questions involving geometry where we have to calculate angles. Let's have a look at an example. So here I have two straight lines that cross over. I know one of the angles is 100, and I want to find the sizes of angles A, angles B, and angles C. Just note that I don't have to find them in the order in which they're asked. So looking at my diagram and thinking about my new rule, vertically opposite angles, one of the angles that I'm looking for jumps out at me straight away. And that's the angle B, because B is directly across from 100, so B must be equal to 100 under this vertically opposite angles rule. So angle B equals 100, and my reasoning is that the angles are vertically opposite. In terms of remembering and learning the rules, it's a really good idea if you're using a rule that has a name to actually write that name down as an explanation at the end of your solution, particularly in a case like this where there was no calculation. Next, I'm going to find angle A. Notice that angle A and 100 are side by side on a straight angle. This means they add up to 180. Can you remember the name of this rule? And it's one of these from the top of the page. Well, the rule that we're talking about is supplementary angles. A and 180 are on a straight line adding up to 180, so they are supplementary angles. I can do a calculation to find A by saying 180 minus 100. So angle A equals 80 degrees. Now I've written down a calculation here, so that's sufficient explanation, but you can, if you like, just for practice and as a memory aid, write down at the end that it's supplementary angles is the rule that you followed. Lastly, I have to find angle C. Now, looking at our diagram, you could say, okay, I can use supplementary angles to work out C, but there's actually a faster way of doing it. Can you see what it is? You might notice that C is directly across from A. And because of this, I can use the vertically opposite rule. I already know how big A is. A is 80 degrees. Since C is vertically opposite from A, it must be the same. I didn't have a calculation to do here, so really I should write down the name of the rule that I'm using to back up my reasoning and justify myself. And C is 80 because it's vertically opposite A. Let's have a look now at a second example. Here I've got one straight line running through my diagram, and I have a line cutting through it here, and a straight line cutting through it here also. And I want to find the values of D, E, F, G, H, and J. It would be a good idea at this point in the video to pause, try and solve these angles yourself, show your calculations, or if that's not possible, give an explanation by naming the rule. Then play the video again and see if you're correct. The first thing to notice is that I'm treating these two parts of the diagram like completely separate questions. They're not really connected aside from this line that travels through both of them. The angles in this bubble are different from the angles in this bubble. So looking at D, E, and F first of all. First of all, D and 40 are supplementary angles. They add up to 180 on a straight line. So I can simply take 40 from 180 to find D, and D equals to 140 degrees. Next I'm going to find F. F is directly across from D. It's vertically opposite from D, so it must be the same size. The angle F is 140 degrees, and I know this because it's vertically opposite D. Finally, I have to find the angle E in this portion of the diagram. Notice that E is directly across from 40, so they're vertically opposite. Again, when I don't have a calculation to do, I should justify my answer by writing down the rule. Okay, that's this portion of the diagram completed, and now I'm going to go on to this portion of the diagram. First of all, I'm going to find G. G and 30 are on a straight line, and they make up 180 degrees. What's the name of that rule again? G and 30 are supplementary angles. So to find G, all I have to do is take 30 from 180. So G equals to 150 degrees. Next, I'm going to find H. Notice that H is straight across from 30. They're vertically opposite, so H is also equal to 30. Again, because I didn't have a calculation, it's a good idea to insert a reason if possible. And finally, I have to find J. Well, the angle J is directly across from the angle G, and so they're vertically opposite and they must be the same size. We've already calculated G. G is 150 degrees, so J must be the same. So J is 150, the reason being that it's vertically opposite from G.